All right, so our last day of new stuff, or kind of new stuff, it's actually the review day for limits. What can we do on this first page, number 7 here? Is this graph going to have any holes or anything? No, it's just going to look like this. So if we want to know the limit at 2, we could graph it, but we could also just do direct substitution. You can graph it if you want and just find that it's approaching the 2. It's approaching the same thing from both sides, but that same thing would be 32. Anybody getting that? Now that it's not going to show up in your standard window, but you could definitely go to the table, put in 1.992 and 2.01, and it should be 32. All right, this is a parabola that opens up. Since we want the limit at 3, it's a continuous, well-behaved function. So we can just put the 3 in, just do it carefully, or graph it and trace to 3. I'm thinking 19. Is anybody getting that? Did anybody get to that one? Yes. Okay. Don't do direct substitution and do it wrong. Then you'd be better off graphing it. All right. I don't know that this is a continuous curve. It looks like we could certainly do direct substitution and get 1 over 1, right? Shall we graph it just for fun because we haven't done one yet together? Is the x squared plus 1 on the top? Oh, okay. And then it's x squared plus 1 in the denominator? Thank you. All right, so a standard graph, yeah, kind of not doing much, right? What did we want to know at? 0? Is that right? So like negative 0.0001, 0, and positive 0.0001. Looks like it's staying at 1, right, at all those places? So we're good? Any questions about that? Are we okay to do this by direct substitution, you think? Seems like it would work if you put a 0 in, right? So we get 1/2, but we can check the graph. It was 2 minus x on the top. And what was on the bottom, guys? X squared plus 4, maybe? Thanks. And it was 0 again for where the limit was? So if we go to the table, all the values we already have in, yep, 0.5. We're good? All right. So you could do those kind of on the quiz easily enough. Let's talk about one, and there is one on the summative, the final, whatever we want to call it, that does have a this kind of a graph. That's what it's called. Okay, this has a limit at 2. So the question is it getting closer and closer to the same y value from both sides? Yes, and what y value is that it's getting closer to? Anyone tell me the y value here? Thank you. This has a special, this kind where it has a sharp turn, has a special name. I think it's called a cusp point in calc, but for today, that's all we need to know. What about this one? Closer and closer to what y value as we approach 4? -3. Number 19. Does this have a limit at 2, and what is it if it does? This is what's going to be on the final, guys. And the choices will probably say 2, 4, does not exist, And I don't know, some other crazy answer like 5, which is right. As you get close to 2, from the left and from the right, what is the y value approaching? 4. It does not matter what it is doing at 2, as long as it's approaching the same value on both sides. We're good? Remember, a limit is not what it does at a value, but near a value. So this one, as you get close to an x value of 2, the y value gets close to 2. What about this one? As you get close to 3, the y value changes from 3 to 6. So the left side and right side limits are different. So the limit at 3 does not exist. Too fast? Do you need me to go back over why that is? Okay. And this one? Yep, as long as it's talking about at 4, it does not exist. All right, can we do direct substitution on both of these? This is a linear, well-behaved line, right? Both of those you could just substitute in. What do you get here? And this is a negative one, right? -3, anybody getting that? That's the kind I would mess up because it's too easy. Okay, this is also a continuous, well-behaved function. So if we put in a -1, what is -1 to the third, guys? Yes, so we get -2. Graph it if you need to. Anybody remember what this looks like? It's a V, yeah. We could do it. Maybe we should practice typing it so we remember where that is. Do you remember where it is? Math, arrow to the right to number, absolute value of 2x. Okay, what did we want to know about at, I forgot, the limit at -3. Okay, that's a nice number. Trace -3, it is at +6. If we go a little to the left, it's still really close to 6. If we go a little to the right, it's still really close to 6. So I'm thinking we're good. Oh, this sounds fun. Sine graph. Yes? So as you get close to pi/2, well, this is what value where we finish one cycle? 2 pi. Halfway would be pi. Pi/2 is here. So as you get close to pi/2, what y value would this be approaching? 1. Yep. That's an important one for calc. Anybody remember what this would be? If you put a 1 in there, ln of 1 would be e to what power equals 1? I'm thinking is, anybody remember? 0. I wouldn't ask that on the final. And you can take the limit of anything positive, so 0.9 and 1.01, it's continuous at that point. Ooh. So the question, this is interesting because you will do a bunch of these in calc. If you put a 0 in, do you see that it changes here to here? But remember, we had a question about, is this continuous or discontinuous? We had a question, and some of you had to retake this piecewise because of that. If you put a 0 in here, what do you get out? If you put a 0 in here, you get out 0. So even though it switches rules, would it be continuous? Would it? This one would go to 0, 0 and be a solid circle because it includes. This would start at 0, 0 and be an open circle, but it doesn't matter because this is included on the graph. So it is it does have a limit of 0 at 0. If you graphed it, greater than 0 is a parabola, less than 0 is a line, but it is continuous. It would look like this, okay? By the way, that goes with this one up here. There's not a piecewise on the final, so don't freak out. If you put a 1 in here, what happens? You get out 1, 3. If you put a 1 in here, it would be an open circle, but it would exist at what? 1, 2. So at 1, is it going to be the same value on both sides? No, there's a jump, okay? If I were to graph that one, it would start at 1, 3 and go up, and this one would start at 1, 2 with an open circle, and it would be going up, but it's to the left. We have a positive slope, but it would go back that way. It's not that steep, but you get the idea. At 1, it's jumping, so this does not exist. Again, no piecewise on the final, but it's good to talk about. All right. I'm going to go with, you could do direct substitution if you need it on those two, yes? Which of these would you probably say, I should graph that? I would say 5 and 6. I think actually there's one like 3 on the final, but it is a problem you can do by direct substitution. So 2 cubed minus 2 times 2 plus 3 would be 8 minus 4. I think it's 7. This one you could do direct substitution. This would be negative 8 plus 2 would be negative 6 plus 5 is negative 1. Anybody checking my arithmetic there? Yeah, I think it's negative 1. All right. This is not defined at all places, and we actually had a question like this yesterday that I did wrong. This is a graph that looks like this, and we can graph it on the calculator. The question yesterday asked us something like this. It was a more complicated question. Okay, this is supposed to be negative 5, sorry. Okay, now I have too many. Anyway, it's negative 5. The question asked, what is the limit at negative 5? And we said 0 because we did direct substitution. It was not the same kind of question, but actually at negative 5, it doesn't have a limit. Does anyone know why? If this question had asked the limit as x approaches negative 5, some of us would have done direct substitution and said 0. But it actually does not have a limit because it doesn't exist to the left of negative 5, okay? It has a one-sided limit. You could say the limit as x approaches negative 5 from the right. That would be 0, but it doesn't have a two-sided limit. I could show you the one from yesterday that we messed up on if we need to, but okay, but this has that 2. So is it continuous at 2? Yeah, over here it's approaching the same y value. What y value is that? Yep. All right, let's graph this because I don't think I know what that looks like. I'm going to go here and get rid of this stuff while I have nothing left in there too. Okay. What was it again, guys? To the 2/3, or was it 3/2? 2/3. Okay, thanks. Interesting. And then it asks about at negative 2. Interesting again why they chose that, but over here at negative 2 it looks pretty continuous, right? We should check though, because sometimes it's not. At negative 2, ooh, that's a disgusting number. I'm thinking it's negative 6 to the 2/3 or whatever this would be, right? Direct substitution. So if we went to the table, -2, what's a little bit below -2, guys? To the left of -2. Okay, that's actually to the right. But it's staying close to that value. That value, in fact, is... Okay, anybody remember how this goes? What is to the 2/3 power do? Guys, you got to know that. What's the top number do? Squares it. So -6 squared would be 36. And the bottom number cube roots it. So I'm thinking if we go back here and we were to put in trace, and we were to put in the, what did we have? The cube root of 36? Or 36 to the 1/3 power? What did I do? Trace. Oh, that was the y value we were getting at 2, right? Yeah, I can't put it in as an x value. Duh. Let's just check on the home screen. The cube root of 36 is 3.3019. Is that what we got here at -2? Yes? Okay. If we scroll up here and over, we get that same ugly decimal. All right. Won't be that complicated on the final. Anybody thinking we should skip 7 and 8? Actually, these are at a variable, so I'm going to skip in this whole section. How's that sound? All right. Explain why direct substitution doesn't work. Why can't I use direct substitution on this question? Yep, -3. It's not part of the domain, right? Makes denominator 0. So how could we do it? Yep, the top factor is x plus 3x plus 4. The bottom factor is x minus 3x plus 3. If we divide that whole out, now can we put a -3 in? So we'd get -3 plus 4 over -3 minus 3, or 1 over -6. Did I do that right? Okay, can you guys try 12 and tell me what you get? Works for me. Again, you could have done those by graphing. It would be undefined at 3, but you should be getting the same value from the left and the right. Oh, apparently I did this one for us already. Does anybody remember how to graph a cubic? Yeah, not so much, right? All right, we can skip it. It's not... This one, it says we could graph by grouping. Anybody remember how that goes? Yeah, if this were on the final, how would you do that? Because you didn't remember how to... Let's go back to that one for a second. Was it x cubed plus 1 on the top? Over x plus 1 or x minus 1, guys? And it wants the limit at -1, okay? -1, undefined. -1 would be close to -0.999. Or what's just above -1? Oh, puts me. -1.001. So what's the limit approaching? 3. Anybody factor by grouping up here? Take an x squared out of the first two and what's left? X minus 2, and then there's an x minus 2 back here. So there's a 1. If we divide out all the x minus 2's, what will be left? An x squared plus 1, and then if we put a 2 in, we will get 5. I'm not going to graph it just because it's not that messy on the final anyway. Says we should do 16 apparently. I think you guys could do 15. Just factor it and divide. Okay, what does it say for 16? Absolute value. X squared minus 4. And then is it divided by something? Parenthesis x plus 2. Okay. I want to see what that graph looks like. Oh, cool. So what's happening at -2? Is that where they asked us to find? Yes. What's happening at -2, guys? Does the limit exist? Sure doesn't look like it. If I go to the table, -2, -1.999, and -2.01, not the same thing, right? One is positive and one is negative. My bank account tells me that positive and negative numbers aren't the same. So this does not exist. Wouldn't have figured that out probably. Got to be careful. I like that graph though. What was it doing? A V up here and a line down here or something? Cool. What's happening here? Can you take a square root of -3? No, does not exist. If you graphed that, it would start over here. So at 0, it has nothing. Okay, this is undefined at 0, so I don't really know what's going on unless I graph it. X minus 2 divided by x squared? No. And, oh, what's this doing at 0, guys? Remember what we write? Yes, we write, you can say it does not exist, but both sides are approaching negative infinity. Decreasing without bound. All right, all we got is some true false, I think. Oh no, this one actually wants a value. All right. Does the, oh, these are one-sided for the beginning. This is good review. What does this mean again? We know Hofbauer's not good at this. Please pay attention, guys, for just a few more. We're almost done. As you approach 2 from the left, what is the y value approaching? Okay, as you approach 2 from the right, so here's 2. I'm coming at it from this way, which means here, the y value is approaching 1. So overall, does the limit at 2 exist? No, because it's approaching different numbers from both sides. I'm not going to write an explanation. All right, 3 from the left. Three from the right. Yeah, it looks like this is 4 up here. So does it exist at 3? Three from the left, 3 from the right. So does it exist? Good job. 1 from the left. The y value is down here at 1. 1 from the right. Y value it's approaching is 3. So all right, now we have a boatload of true false, but these are really good questions. Does the right hand limit at -1 equal 1? So coming at -1 from the right, would I get 1? Probably look up here because on your paper it's really hard to tell what's going on, but it is true. As I approach 0 from the left, am I getting close to 0? Y value is getting close to 0, right? As I approach 0 from the left, I'm getting close to 1. You just told me it was 0, so it can't be both. Is the left-hand limit and right-hand limit at 0 the same? As I approach x equals 0, is it the same from both sides? Nope. So does the limit at 0 exist? The limit at 0 is 1. No, you just told me it does not exist. All right, now we're moving on. The limit at 1. Here's an x value of 1. Both sides are approaching what y value? 1. So this is false, but this one over here is true. Limit at 1 is 1. Limit at 0 is 0. You just told me it didn't exist, so that's false. Limit, okay, at 2 from the left is 2. Here's 2. Coming from the left, does it appear the limit is 2? Yeah, it's supposed to be. It's just hard to see. That was a really bad one to be able to tell, especially after I scribbled on it even more than it already was. Is this our last question? Maybe? Yes? Okay. Coming to the right towards -1. From the right towards -1. Are we at 1? Right here. What y value am I at? If I come at -1 from the right, that's what this means. Am I at a y value of 1? True or false? True. Now I need to see if I can erase that without. Oh, I could. Didn't erase the picture. Limit at 2 does not exist. Here's 2. Does it have a limit at 2? Both sides from 2 are approaching 1. So does not exist is false. The limit at 2 is false. Okay, the limit at 2 would be what? Be 1. All right. Now I got to erase again. Let's see, what else is it asking quick? 1 from the left. 1 from the left is y value of 2, so that's true. 1 from the right is a y value of 2, not 1, right? Does the limit at 1 exist? So does not exist is false. Okay. The limit at 0 from the left and right are equal. So 0 is here. Is this approaching the same value from the left and right? Okay. Last ones, great important questions. Is there a limit for everything from -1 to 1? From here to here, does every point have a limit? No, because there was a break in the graph at 0, so this is false. The limit exists for everything from 1 to 3. Okay, the whole is here at 2, but is there a limit at 2? Yes, so this is true. Did we do the whole packet? We rock. All right, so